In this video, you need to be on the page in your notebook that says Matter Matters, and we're going to work on part 1, which is light. And in it, you're just going to need to, for the very first part, if you read steps 1 through 4, we literally just looked at a prism. So we took a prism, as I'm going to show you here, and we just kind of looked at it. And you can even look at it as you look through there, and you can kind of see some colors changing. And if you get a chance in class, you can take a look. But you can kind of even see the rainbow down at the bottom a little bit, just some colors. You can see the images kind of bouncing around. If I move it away versus moving it close, you might notice something different. So then they just wrote down their observations in the box. And then we turned off the lights. And after we turned off the lights, they shined a light underneath it. So I'll show you, kind of took a flashlight and we put on top of it a prism, and then we turned it on and shown it on the ceiling. And then they answered the rest of the questions on this page, A, B, and then C has a box on the back that you can answer or draw the diagram. So I'm going to show you a picture of what they would have seen on the ceiling. Hopefully this comes out. That's kind of what they saw on the ceiling. And they could change that around. If they moved the prism around, you know how we had the prism? So if you moved the prism around, you could kind of change that rainbow into different things. So it make it crisper if you moved it kind of away or away from the flashlight. So if you get a chance, you can try it. But if you move it like away from the flashlight versus towards the flashlight, and if you turn this, it would kind of make different kinds of rainbows. It would kind of change it. Make it either more crisp or blurry or bigger or smaller. So pause the video and finish part 1 light. Okay, at this point I'm going to assume you have finished part 1 light, and in the box here's some of the descriptions like I was telling you some people would have made. And then you had a question A that I don't have on this answer sheet, so all the descriptions of the observations are in the box. And then here's what most people would have put for B. So just read through that. And then where the box was on C, I don't have the picture, but the models would have shown the white light going through the flashlight and bending when it hits the prism, so it splits into these different colors. Okay? So basically what you're supposed to get out of that is it came in as white light, but then as it went through this prism, which is a solid, it would start bending into different kind of colors, all the different colors in the rainbow. Then we worked with sound. So with the first part, we took 2 tuning forks, and we just, one was small, one was big, and we just hit both of them and then made observations. And so you would answer questions 1, 2, and 3 on 111, or on that page. And then there's a question 4 on the back. So in your notebook, I mean, it's not 111, I'm sorry, not 111. But it's on your notebook, it would say Part 2 Sound, and then they would investigate the 2 tuning forks, and they answered 2, 3, and then on the back was a 4, box. And then, so I'll show you that, and then you can make your observations. So they had a small tuning fork versus a, see if I can find that, larger tuning fork. So I don't know if you can see the difference, but large versus small. Alright, so I'm going to hit the smaller. Okay, that was the smaller. And then now the larger. Okay. And then, again, smaller versus larger. Okay. And then, so I'd pause the video and you would finish those 4 questions. Okay, I'm assuming you paused the video. And you would notice that the pitch of the larger tuning fork was lower and the pitch of the smaller tuning fork was higher. And then it says describe the sound waves. You would have a lower frequency, so you would have this longer wavelength for the larger tuning fork because the pitch is lower. And the sound wave for the smaller tuning fork would have this higher frequency, so the pitch was higher, and that would make the wavelength shorter for that one. So, and then on the number 4, what you would have seen was if you had diagrammed, you should draw this is a description, but this is what a description of the diagram would look like, showing that longitudinal wave going from the tuning fork to the person's ear, and then labeling the compression, the rarefaction, and then of course your source being the tuning fork and your receiver. And you should have had a picture for each, the small versus the large. Okay, then the last part that they did was they took the tuning forks. They only took the small one, and they did an investigation where they tried to see how long the tuning fork would vibrate. So on steps 5, 6, and 7, you can see we're only going to take the small tuning fork, and each group member would try this. And so you can see where it says tuning fork held next to ear, which is kind of right down there. Each person would take turns, and they would hold it next to their ear, not on there, but next to their ear, not touching their face or anything. So, and then one person would have the timer. So one person would have this timer. So we turn it on. Okay, and then one person would have the tuning fork, and they would hit it, and you're not going to see me putting it next to my ear, but you're going to see the timer, and they would not touch their ear. But as soon as it went next to my ear, I'd hit start, and when I don't hear the tuning fork at all anymore, I'm going to tell the person to stop. So I'm going to do one of them. You can get the data from the rest of your team, but I'm going to do one of them. And if you get a chance, you can get a tuning fork and try this yourself. So ready, set, whoops, sorry, that didn't go very good. Oh, I messed up. Okay, let me start over. Okay. Stop. Okay, so on your paper you could write down 10.92 or about 11 seconds. And then the next person would try it, next person would try it. Well, in the next part, what I'm going to show you is each team member then took it, and instead of putting it next to their ear, they would hit it, and in the back of their, they would touch the heel of the tuning fork with the back of their ear, which is called the mastoid process. It's the bone, and you can see the diagram there in both a real live one and then one that just kind of shows you where the mastoid process is. And then they would see how long it would take for them to hear the sound. So I'm going to do it again, reset. But now this time, you're not going to see me doing it, but I'm going to be touching it with the back of my ear. You're just going to see the time. Ready, set, go. Stop. Okay, in about 4 seconds, 4.5, don't hear it anymore. And that's about right on average. So now they would go back and they would fill in the rest of 7, 8, and actually they would finish this all the way through the conclusions. So pause the video and go ahead and finish through the conclusions, the entire thing, and then come back and see if you get this kind of what we got. All right, I'm going to assume that you've paused the video and tried and answered all the rest of the questions. But basically, you would get a higher number. If you look at step 7, you'd get a higher number like 15 when it was held next to your ear, versus if it was held on your mastoid process, it'd be a lot lower, like 8. So I think I had gotten almost 11 and then like 4 seconds. It just depends on the person. And then it says, so if you compared it down, you should have been a little louder as well. You would notice it was next to your ear. It was a lot louder than if it was near your ear. And it was also a lot longer when it was held next to your ear. So that's what most people noticed. And then for the rest of it, it was more intense when it was next to your ear, meaning louder, more intense. And then when you drew, you should have drawn 2 diagrams, and you would have seen next to it that the model, when it's placed next to the air, it's traveling through the air to the air drum, maybe some air dots, something like that. When it's held on the mastoids, you're traveling through the skull to get to the inner ear, which you should be able to figure out at this point since it took longer and it's not as intense. It's more difficult to get through that skull, that medium, so it's more difficult to get through that solid, that bone, than it is through the gas. Which leads us to our conclusion statement. Where we are trying to get to is, students, you should have reasoned at this point that waves from one medium to another changes those properties of waves, and the way that energy they're transferring is perceived. So mostly when it's traveling through a gas, it's a lot easier to travel. The waves have a lot easier to travel than if you were going through a solid. So it's changing those properties of waves when it goes through different mediums.